Particle physics is the branch of physics that studies the properties and behavior of particles that make up matter and energy in the universe. These particles include protons, neutrons, electrons, and many others that are even smaller, such as quarks and leptons. Let's dive into the history to know how particle physics evolved. The history of particle physics dates back to the late 19th and early 20th centuries, when scientists first began to study the properties of atoms and the particles that make them up. In 1897, J. Thomson discovered the electron, which helped to disprove the prevailing plum-pudding model of the atom and led to the development of the modern atomic model. In the following years, other subatomic particles were discovered, such as the proton and the neutron. In the 1930s, physicist Enrico Fermi proposed the theory of beta decay, which helped to explain how certain subatomic particles change into other particles. During World War II, the development of the atomic bomb led to a significant increase in funding for nuclear physics research. This, in turn, led to the construction of large particle accelerators such as the cyclotron, which allowed scientists to study the properties of subatomic particles in greater detail. In the 1950s and 60s, a number of new particles were discovered, including the meson and the pion, which helped to establish the field of particle physics. In the 1970s and 80s, the discovery of a new family of particles called quarks, proposed by Murray Gell-Mann and independently by George Zweig, which are the building blocks of protons and neutrons and other particles, led to the development of the theory of quantum chromodynamics, QCD, which explained the strong force. Nowadays, particle physics continues to be a very active field of research, with many ongoing experiments and projects aiming to understand the properties of subatomic particles and the fundamental laws that govern the universe. Particle physicists use high-energy accelerators to create and study these particles, and they also use detectors to observe the particles produced by these accelerators. This helps them to understand how the universe works at its most fundamental level. By studying the properties of these particles, particle physicists are able to learn about the fundamental laws that govern the universe. They also have the hope to understand the nature of dark matter, the Higgs boson, and other yet-to-be-discovered particle. There are many different types of particles that make up matter and energy, but in general, they can be divided into two basic categories: fermions and bosons. Fermions are particles that make up matter, such as electrons and quarks. They have half-integer spin and obey the Pauli exclusion principle, meaning no two fermions can occupy the same quantum state simultaneously. Bosons, on the other hand, are particles that carry forces, such as photons and the recently discovered Higgs boson. They have integer spin and can occupy the same quantum state simultaneously. Fermions are the building blocks of matter and make up protons and neutrons. Bosons are particles that mediate the fundamental forces of nature, such as the strong and weak nuclear force, electromagnetism, and gravity.